Welcome everyone to the first episode of To The Point with Greg and Grant. This is a podcast that gets to the point, stays on point, and makes a point. We are focused on the aerospace and defense industry, the challenges being faced, and the capabilities currently available commercially to meet those challenges. We will be speaking with a number of folks from different organizations on a variety of aerospace and defense topics during these podcasts. And to introduce myself, my name is Grant Trifo. I'm an account manager for analytical graphics, better known as AGI. Over the past 12 years, I've had the pleasure to help numerous clients across the US and Canada identify core problems, some of which they didn't even know they had, and solutions to ensure mission success. Sitting next to me is my co-host, Greg Dermond.
All right, thank you, Grant. Appreciate it. Hello, everybody. My name is Greg Dermond. I am the enterprise manager, and I also help lead up our DC business unit for AGI. And you may have come across my name in the past. I've held a number of different positions covering a lot of different areas around the country. And I'm super pumped to be part of this podcast as we look forward to producing really good content for you. And especially as the aerospace and defense industries continue to grow and advance, we think this forum will be an important vehicle to meet the demand for information relevant to the broader aerospace and defense communities, especially for future podcasts. So I look forward to talking more with you in the future.
Okay, enough of that. Let's get to the point. We are being joined today by AGI's Chief Remote Sensing Engineer, Patrick North, for a discussion on the new enhancements to STK 11.5. Pat, thank you very much for joining us.
Hey, Grant. Hey, Greg. It's great to be here. I'm glad to talk to you guys about this stuff. This is what I do every day, so it's easy because I have fun with it. So
excellent. All right, so my first question is, putting myself in the shoes of someone who's very familiar with STK, I might be asking myself the question, why do I care about the new 11.5? What's in it for me?
Yep, great question. So we actually just had the Space Software and Defense Expo where we talked a lot about that. We have a lot of existing SDK users who are doing great analysis, and one of the things we're constantly doing is we're listening to what their needs are so they could do more with the tool that they're trying to use anyway. And for 11.5, the big new things are we added new capabilities in Astrogator so we could do low thrust modeling and optimization. We added new capabilities with multifunction radar. We added some GLTF modifications for doing really fancy graphics and visualization. And we also added new enterprise updates too. So if you're working with a big team, how can we help them better work together as a team to do coordinated analysis?
Oh, that's huge.
Yep.
And so let's talk about one of the major enhancements has to do with the Astrogator module, which is a specialized analysis module for satellite maneuver planning.
Yeah.
Can you talk more about those enhancements within 11.5?
Yeah, so one of the ideas is folks are trying to do more with less. So we've got lots of satellites that are trying to transfer orbits with low thrust engines. So the idea is historically you had a limited amount of fuel and you do a big thrust to maneuver and change your orbit from one to the other. And you have a very precise short amount of time where you burn a lot of fuel. And what we're finding now is you can actually go farther with a smaller engine, less weight for the fuel, and you can continually be thrusting to get yourself into the eventual orbit. So rather than that one big burst of energy to transfer orbits, we're now doing continual gradual transfers. So the idea is if you wanted to save power and save weight, you could use one of these low thrust engines. The problem is it's hard to predict. Okay, well, what's the sequence of events? If you're trying to constantly step on the gas and aim at the eventual target, planning that out ahead of time is hard. And one of the things that Astrogator strives to do is to make this planning easier. So what you can say is, I'd like to start here, I'd like to end here, and Astrogator will actually optimize that low thrust trajectory path to get you where you want to go the best way possible.
Oh, that's great. Yeah, and speaking with a number of our customers, low thrust comes up quite frequently.
Yep.
More and more every day.
Yeah, I mean, the idea is if you can save that power and weight, that those are valuable resources on a satellite system. What could you do now for your primary mission? That's just the taxi getting me from point A to point B. But once I'm there, what do I want to do? And if I can save more weight and more power to do my eventual mission, that's fantastic. All of a sudden, I've got a much more effective, both in performance and cost system.
Right, you get to do more.
Exactly.
Yeah.
More of what we really want to do.
All right. Well, one question that I had was on the multifunction radar, because, again, speaking with folks, it seems like behavior modeling type of capabilities is just becoming more and more prevalent. And I kind of view the multifunction radar as a very good step for AGI towards that area, that analysis area. And I was hoping maybe you could elaborate a little bit more on the capabilities that are now available in 11.5 and how that would help folks.
Yeah, absolutely. So the impetus is, in theater, you're not sure what you're going to need to do. So it doesn't make sense to have hard-coded, single-function radar tools anymore. You might have a new mission that you need to start performing on immediately in the middle of an operation. So the idea is with multifunction radar, you can have some of that behavior modeling where you can say, all right, I might be doing a broad area search, so I'm sending a lot of energy over a really large amount of area, and I'm looking for any return possible. But all of a sudden, something important came up, and now I need to start precisely tracking that. So I'm going to send, while I'm doing my broad area search, I'm also going to be doing a focused detection and tracking on a smaller object. So I'm going to be sending more energy in a smaller area with more precision ranging. That's the focus. So I might have two different completely separate jobs. So the idea is the radars can now operate, instead of just a single function type of tool, you can now be a smart PC where you can load in different programs, you can change the parameters midstream, you can do software updates to change how you're performing and operating in the middle of theater. So now instead of just having a single use, you can now have a really flexible range of what might come up in theater years after you were originally being developed and built. So now you can repurpose a lot of these for entirely new missions.
Very powerful. Another enhancement has to do with our SDK Aviator module, which I've been getting a lot of questions about from from the customers out there. And Aviator, for those that are listening, gives you the ability to include real-world aircraft performance in your flight design. So can you get into the enhancements of...
Yeah, absolutely. So Tom Neely, our developer, he's actually been adding new guidance modes that are more realistic. So if you have a new type of guidance strategy that you want to execute, you can do that. For me personally, I'm a sensor guy. I like to do sensor performance and analysis. And one of the important updates was with hypersonics. So Aviator, as you're flying your aircraft at hypersonic speeds, Aviator will tell you what your leading surface edge temperatures are. So based on this altitude, you're traveling through this much atmosphere. If you're going this fast through it, so if your velocity is Mach 5, Mach 6, here's what your surface temperatures would be. And that thermodynamics model, I can actually take and look at with my EOIR module, my sensor module, and I can say, all right, visibly, is this thermal signature detectable from these angles when it's flying with these properties? So all of a sudden, now instead of just doing this for maybe thermodynamics modeling for the aircraft body, you can say also for a detection purpose, what does that now look like? So taking the benefits from one model, you can now use it with all the other aspects of SDK. So hey, now that we can do this, what else can we now exploit from that?
That's huge, especially with what you're reading and hearing in the news these days.
Absolutely, yeah. Yeah, nobody's sure what it's going to look like. So one of the best things that we can do right now is with modeling and simulation. We can tell you exactly what it's going to look like based on the laws of physics.
Yeah. That's great. Thank you for that. Lastly, wanted to see if you could talk more about the SDK Data Federate, which gives users a collaborative environment. Can you get into that?
Yeah, absolutely. So that's part of the enterprise update where we wanted big groups of folks to be able to work together easier. So if you have a lot of system engineers and maybe you have your astrodynamics folks that are doing orbit determination and they're going to set up the orbital properties, then you're going to have your comm folks test out their analysis, and then you're going to have the power folks do their analysis. The idea is the SDF, the SDK Data Federate, lets them all save their scenarios in one location so they can all work off of them easily and you can pass them on to the next person in the line. The other pieces of the enterprise that are a part of that, so now we have a common workspace that we're all working from. But what if we're looking for terrain data? Well, now with the terrain and imagery server, you can say, all right, here's our terrain that we're going to use for this mission, for this analysis. We invested in collecting this type of imagery, this type of terrain data. Also, we're going to be doing big analysis, so scalability lets you say, well, let's make use of our giant cluster of computers, or maybe I want to use all the cores on this 56 core box. So scalability lets you do more analysis faster. And finally, the last piece of it was if you want to present this to a decision maker, maybe they don't have SDK on their desktop, but you want to show it to them. Well, you can now use a web-based interface to launch SDK and run a lot of those through the frames simulation.
Gotcha. And then lastly, as time is winding down here, can you explain to the listeners, how does AGI and the development team rack and stack all the inputs that come from the marketplace?
They don't feed us. The idea is, so one of the things that we do is with the expo, we were actually going there specifically for outreach. We wanted to have a tech zone there so we could talk to all the folks that had hard problems and have a subject matter expert and a system engineer go there, bring up SDK, show them what it can actually do, and see, oh man, my life would be so much easier if I could do this or that. And then we write all those features out, and we have sort of, I look at an X and Y axis, and on the X axis, we have how hard each of those features are to develop. Maybe it's going to only take me a week, maybe it's going to take me 6 months. So it'll be somewhere on the X axis, and the Y axis is how important is it. So if we have a lot of feedback from the field, from our current customers, from potential customers saying this is what we really need, that lifts things on the Y axis. And what we do then, we scrape along the top curve of that, and we say, all right, here's the easy stuff we can get done in no time. Here's the bigger, heavy duty, really important stuff like multifunction radar, like low thrust optimization, like the hypersonic thermal modeling. So that's usually how we go about optimizing our development flow.
That's fantastic.
Yeah, that's excellent. Yeah. All right, well, we are just a little bit past the 10-minute mark. So, Pat, we wanted to thank you very much for joining us today. Your the information you shared and the insights, it was just great.
Thank you.
So, now to wrap up the very first episode of To The Point, we would like to do so with a fun fact. SDK is currently comprised of over 8 million lines of code and growing every day. It's quite the development effort. So the point we're making is recreating a commercially available tool like SDK that is continually being enhanced. It just doesn't make sense. Not from a dollar standpoint, nor from a time investment standpoint. Thanks for joining us.